Okay, so we want to talk about the linear inequalities in two variables. So we have learned the linear equality in two variables, which is ax plus by equals a constant c, right? This is a linear equality which represents a straight line, okay, a straight line. And what about the linear inequality? Linear inequality is given by this kind of form, ax plus by greater than c, or greater than equal to c, or less than c, or less than equal to c. Okay? So this is called the linear inequalities in two variables, x and y. So what's the graph for the solution for this inequality? It should represent a region. Okay, it should represent a region. So now let's look at one quick example. That x plus y, okay, equals 1. So x plus y equals 1, which is given by this if you draw the graph. So this is the, we find x-intercept, y equals 0, so x equals 1. So this is 1, okay? And y-intercept, x equals 0, so y equals 1. So 1 here. So it goes through these 2 points. We can connect these 2 points. You draw a straight line. And this line is on all the points on the line, xy points on the line satisfy x plus y equals 1. So this is x plus y equals 1. And what about the region below this line, which is sometimes called the lower half plane or the left half plane? What about the region below this line? Okay, this region, this red shaded region, has the boundary x plus y equals 1. And this red region represent x plus y less than. We notice that if you plug in any number inside this x plus y, okay, you will see x plus y is always less than 1. Any point, for example, you plug in 0, 0 point, 0 plus 0 equals 0, 0 less than 1. For this blue region, which is called the upper region, or the right region of this line, this is the represent x plus y greater than 1, okay? So, and the black line is the boundary, which is called x plus y equals 1. So what about x plus y greater than equal to 1, which is the blue region plus this line? What about x plus y less than equal to 1, which is the red region plus this line? Okay, so now let's look at some examples. And in these examples, you will see the typical way to solve, to sketch the region for this inequality. So in other words, the solution for the inequality, linear inequality, represent a region. Okay, represent a region. So now let's look at this example. What about y less than -2? What is that? So now the first thing we need to do is we need to draw the graph for y equals -2. So -2 is here, right? So y equals -2. Where y is less than -2, you choose any point. So this line divides our xy plane into 2 parts. One is the left region, one the other one is the right region, right? So you just pick an arbitrary point and plug in to see if to satisfy this inequality. For example, if you plug in 0, 0 point, okay, we always choose the origin because it's easy, right? Origin is not on the line. So we choose 0, 0 point. So in other words, y equals 0. 0 less than negative 2, no. 0 should be greater than negative 2. So this region including this y equals 0 and x equals 0 region, this region, the right half plane of the right region represent y is greater than negative 2. So the other half would be y less than negative 2. So this is the y less than negative. So, but here's one thing very important is, since this one is always less than, not less than equal to, so the boundary should not be included, right? So the boundary, so we use the boundary, we use the dashed line to denote the boundaries that it represents that the boundary is not included, but should be left side of this dashed line, but the dashed line is not included. Okay, so this is the y less than negative 2. So the first step is you always draw this is the first step, draw the line y equals negative 2, right? And this line divide our plane into two regions. Then test a point, okay, to determine if this region does not satisfy this inequality, that means the other part would be the region for this inequalities. Okay, so now let's look at another example. 4x plus y less than equal to negative 2. Okay, so the first thing is we still need to draw the graph for 4x plus y equals negative 2. Okay, so we can pick arbitrary 2 points. One point is x equals 0, y equals negative 2, right? This is the one point. The other point is y equals, for example, let me think, y equals 2. X should be, if you plug in y equals 2, y equals 2. So 4x plus y equals negative 2. So y equals 2. So here's 2. Right? So 4x equals negative 4. So x equals negative 1. So negative 1 is another point. It's not necessary to be the x-intercept and y-intercept. You can just pick arbitrary 2 points. It's convenient for us because these 2 points have the integer coordinates, right? So 0, negative 2. 0, negative 2 is here. 0, negative 2, 1, 2. Negative 1 and 2. Negative 1, this is negative 1, 2. 1, 2. So it's here. So we draw a line. So this line divides our plane into two parts, right? One is on the left, the other one is on the right. So which region, which half plane would be the solution for this inequalities? So we just test a point. Let's test a point. You can choose arbitrary point. So here, for our convenience, we choose 0, 0 point. So you plug in 0, 0 point into 4x plus y. Plug this test point into 4x plus y. So 4x plus y, so 4 times 0 plus 0, which is equal to 0. 0 is greater than negative 2, right? So in other words, the half region containing the origin would be greater than negative 2. So the other half would be less than. So this is the region. Okay, so this is the region which satisfies these inequalities. So what about the boundary? If the boundary should be a dashed line or the solid line. The dashed line means the boundary is not included. The solid line means the boundary is included. So here, since we have less than equal to, so this boundary, because it has equal to, so this boundary should be included. So this is the region for the solution. Now let's look at another example. 4x minus 2y less than equal to 8. Okay, so the same thing, we need to draw the graph for 4x minus 2y less than equal to 8. Equal to 8. So we can choose some x-intercept. So x-intercept is y equals 0. Y equals 0, x equals 2, right? Or x equals 0, y equals negative 4. So this is the graph. 1, 2, this is the 1 point. And 1, 2, 3, 4. So this is negative 4. This is 2, right? So we connect these 2 points. Not good. So this is a solid line. The reason is it's less than equal to. It contains the equal sign. So this is a solid, not a dashed line. So which region? So we pick an arbitrary point for our convenience. We pick the test point. We pick a test point. Okay, we can pick an arbitrary test point. You can pick 0, 0, or you can pick here. This is we pick the test point, so this time we don't pick the origin. But most time, if you pick the origin, it's much convenient. So, but for the illustration, I will pick an arbitrary point. So this is the point which is 0, negative 1, right? 0, negative 1. We pick this point, 0, negative 1. Then we plug in this point into this linear inequality. So this is the 4x minus 2y, okay? So we plug this point into the 4x minus 2y. So I write down the result. So 4 times 0 minus 2 times negative 1, which is equal to 2. 2 is less than 8. No problem. So this is the region we are looking for, the region containing this point. So this is our region, okay? This half plane is the graph for the inequality. This is right, less than equal to. So this is the graph for this inequality. And this boundary is included because it's less than equal to. So now let's look at another example.